Next up is Shiqing Tsai, student at the University of Wisconsin-Madison, presenting in person.
Hi, everyone. My name is Shiqing Tsai, and I'm a master's student from University of Wisconsin-Madison. And my presenting today is surface-enhanced Raman spectroscopy analysis of imidacloprid pesticides in environmental water matrix. Here, pesticides is one of the popular emerging contaminants, and Wisconsin is well known as its farming and agriculture, for example, dairy and corn. In order to increase the corn production, imidacloprid is one of the popular ingredient in pesticides for products. It starts using in 1990s in the United States as seed treatment and sprays because of its low toxicity to the mammalian and its effectiveness against the pest. So it's really popular. It's frequently used in Wisconsin as an alternative for atrazine and other pesticides. But recently, studies find imidacloprid is toxic to aquatic animals, and it has a lethal effects for the non-targeted species like honeybees. In the bee risk assessment document posted by the EPA, more than 10 cases from 12 states in the United States reported honeybee population loss has highly related to imidacloprid. So also depends on the dose, duration, and frequency of exposure. It has a severe effects to human health from oral injection. So that's why we have to find out the method to detecting imidacloprid in the water. And also Wisconsin reported has finded imidacloprid in Wisconsin Central Sand region, which is really bad for human health and pollinators such as honeybees. So that's why Wisconsin proposed enforced standard as 0.2 microgram per liter or 0.2 parts per billion or of imidacloprid. Also, Minnesota Department of Health proposed health guidance value for imidacloprid as 2 parts per billion. So here is the chemical structure of imidacloprid. Now you might wondering how imidacloprid has been tested or in water. So EPA proposed environmental chemistry method as GCMS and HPLC. Also in Wisconsin, the solid phase extraction followed by the LCMS is the standard method for imidacloprid analysis in groundwater sample. Here, the picture shows the process of LCMS. So the advantage of the standard method is as its high sensitivity and resonance. Also, the detection limit for imidacloprid is 0.1 microgram per liter. However, because of the needed or complex sample pretreatment, as you can see from the figure in the previous shown, the detection process is expensive and time consuming. Also, well-trained technician is necessary to conduct this analysis. So that's why I propose one alternative, which named surface enhanced Raman spectroscopy as uh, um, offering several advantages over traditional methods. Raman spectroscopy is a non-destructive analysis technique. It works by shining a laser on a sample and measuring how the laser light scatter over the molecules as shown in the figure. This scattering produce a unique pattern of lights, can reveal chemistry, structure, and composition about the analyte. In this case, it's imidacloprid. Then SIRS is a technique based on Raman spectroscopy when light shining on metal surface. In this case is citrate-coated gold nanoparticle. Then the signal on or near the metal surface will be enhanced by the surface plasma resonance. So that's why you can see as the bottom right, with only imidacloprid in the solution, it has non-peaks shown or minimum peaks. But after adding the gold nanoparticle, the spectrum is really beautiful. So now let's take a closer look at the results obtained from this method. This figure shows the result of the SIRS or imidacloprid. Each line is one output of sample from its corresponding concentration, and it's called spectrum. I use analytical standard imidacloprid powder and dissolved it into the solvent. 100 micromolar is the highest soluble concentration of imidacloprid. So I started from 100 micromolar to the lowest value of 0.001 micromolar, which is the same magnitude of Wisconsin proposed enforcement standard. Based on the literature review and decision making, I define the primary fingerprint bands of imidacloprid, which are shown here and shown as the red dashed lines. Then also I find out the primary bands of citrate as shown in the blue dashed lines here. So also I define the changing heights of each band from high to low concentration as the concentration gradient, defining the unique pattern of imidacloprid spectra. Here, in order to test the affiliation of imidacloprid absorption on the surface of gold nanoparticle in complicate ionic water matrices, I changed the water matrix from deionized water to environmental water matrices. I collect lake water from Lake Mendota in Madison, Wisconsin as surface water sample and tap water from lab. Then you can as the groundwater sample. As you can see from these figures, the pattern of imidacloprid spectrum exhibit the same quality as in the ionized water. You might notice the differences between 0.01 micromolar, 0.001 micromolar, and 0 micromolar is subtle. So my hypothesis is the reduced amount of imidacloprid in a low concentration as 0.01 or 0.001 micromolar results in the changes of orientation or surface absorption at gold. So in order to increase the resonance of this method, I applied the PCA principal component analysis. As I obtained the 10 parallel setting with different tap water samples in different days during the summer last year. The results is shown on the left. Here you can see I apply 10 sets of each concentration into PCA, and it successfully classified the concentration from 0.01 micromolar to 100 micromolar with the background as 0 micromolar. So I define the detection limit of this method is 0.01 micromolar, which in turns is 2.6 microgram per liter. So in the summary, based on the fingerprints Raman spectrum or imidacloprid, a semi-quantification analysis down to 2.6 microgram per liter was achieved, which is in the same magnitude of health guidance value in Minnesota. However, it is 10 times higher than the proposed enforcement standard in Wisconsin. So more research or studies is needed to be done to lower the detection limit of this method. It can be done by either manipulating the gold surfaces or subtract the background from the low concentration. So all in all, this method is a replicable, inexpensive, and rapid method for detecting imidacloprid in environmental water samples. It can be used in early warming system for groundwater or drinking water. And I wanted to thank my professor and my group's members shown in the picture. And also I really appreciate all the funding agencies. Thank you very much.
Hi, I have a technical question, and I ask your forgiveness because my experience with Raman spectroscopy is very narrow and only for using it to identify the polymer types for microplastics. So my question is you mentioned that it's non-destructive. When I use Raman for microplastic polymer identification, I have to be really careful with my power laser settings and the length of time because it will burn a hole in the microplastic. So I'm just kind of wondering, like the protocol you're using, do you have some sort of like protocol guidance on like your power settings and how long for it to not, and also I've never used it with like liquid or something. So things might be different. Okay.
Yeah, I forgot to point that out. I use the more commercial size with the Raman spectroscopy. So it only testing the solution. The laser power is 785 nanometer, and it only takes 3 seconds to scan the to like shoot the laser to the water sample and get the result. So that's why it's non-destructive.
So it's faster than doing it with microplastics.
Right.
I'm also not, I mean, I've run a million or a ton of samples on Imidacloprid, but never with this technique because obviously it's new and stuff like it. And I don't know the Raman, but do the different peaks correspond to different molecular features? And for example, if you had some sort of a transformation product like where you would have a loss of the nitro group on there, would you lose a specific one of the specific bands or something like that?
Yeah, it definitely has some selectivity on the surface of the metal substrate. So that's why I had to detect the different, I had to build the library of different chemistry in the water sample. So in order to like testing or confirm if that chemical is, or the peaks will be imidacloprid or nanochemicals.
So none of the metabolites or anything like that are built, right?